Each year, Microsoft Research hosts hundreds of influential speakers from around the world, including leading scientists, renowned experts in technology, book authors, and leading academics, and makes videos of these lectures freely available.
Hello, everyone. Welcome back. Thanks for coming back to us after dinner. Let me first just say that we'd love people to provide questions and also just to sign up for more information. So as a reminder, if you have any questions, you can go to this first website in yellow and send questions, which will go to the panel later on. Or if you're just interested in signing up to get more information, please go to the second website there and put your information there. Or we also have pages distributed around the room, and you can just write your email address on those, and we'll collect those. Also, in case anyone wants to ask questions and is having difficulty doing that because of web connections or whatever, then it's okay just to write them on a piece of paper, and if you bring them over to the corner here, either Victoria or Mike will be happy to take those questions. We'll pass them through to the panel. So maybe I'll just give a quick recap of what we've covered so far. We're at the start of our third session, but just to remind you, in our first session, we talked about near-term issues that focused on legal issues, economic issues, and matters about data, among other things. In the second session, we talked about if, how, and when we might be able to achieve human-level artificial intelligence. And in this, our third session, we're going to talk about the issue of, well, what if we succeed? And I think perhaps we can interpret that a bit more broadly to mean, what if we continue to be able to keep improving dramatically the level of intelligence that we're able to create inside machines? And we're going to focus on what research should we focus on today in order to try to help ensure that we get a beneficial outcome down the road. And thinking about that, I was very encouraged by a comment that Shane made in the discussion in the last panel, where he described this as a good discussion to have from time to time. So this is a good time for us to have that discussion. The format is going to be, we'll have two presentations and then another panel discussion. So let me just get started with the next presentation, which is going to be from Nick Bostrom. Nick is probably known to many of you. He's a professor of philosophy and also the director of the Future of Humanity Institute at Oxford. He's also the author of the recent best-selling book, Superintelligence. And please join me in welcoming him to our group here.
The moment of truth. And there we are. So yeah, thanks for organizing this exciting event. So this Future of Humanity Institute, we're a multidisciplinary research institute with mathematicians, computer scientists, philosophers, trying to think carefully about really big picture questions for humanity. And one major focus is on the future of AI. Which I think has a great potential to benefit the world in the short term, and an enormous potential to do so in the longer term. And to realize that potential, we will need to confront a variety of different issues. We've talked about some of them already today. So some of the nearer term issues are familiar. But what I'm really most interested in is this question that you mentioned: what happens if we actually succeed? All along, since the very beginning of AI, the ambition has not just been to automate specific tasks, but it has been to produce true intelligence, the same powerful general learning and reasoning ability that make us humans smart. So this looks to me that it could have enormous ramifications, enormous consequences for the world. There have been a small number of previous major transitions in human affairs. The Industrial Revolution springs to mind, where we figured out a way to mechanize physical labor. And that had major impacts, not just on the economy, but on society, on culture, on the human condition itself. I think that the transition to the machine intelligence era, when we learn to mechanize also thinking, will be at least as momentous as the Industrial Revolution, and probably perhaps better analogized to the very rise of the human species in the first place. Given that the potential impacts are so enormous, it seems very worthwhile to start thinking hard about this, even if we are uncertain as to how far away we are from this, even if we were not sure that this would happen at all, even if we just assign some modest probability to this. Given the enormous values at stake, if there were even some modest way that one might contribute to increasing the prospects of a good outcome by devoting careful thinking to this in advance, that might have a very high expected utility. So I don't think it is true that the case for working on AI safety or for thinking about the impact rests on some assumption that we have enough evidence to be confident that this is just around the corner. Like, that just isn't part of the reasoning of most people involved in this. That said, we did a survey a couple of years ago where we asked a number of leading experts various different questions, one of which was, by which year do you think there is a 50% probability that human-level machine intelligence will have been achieved? And for the purposes of this survey, we defined human-level machine intelligence as the ability to perform almost all jobs, at least as well as a typical human. And we also said conditional on there being no global catastrophe that destroys civilization. And so as you can see here, the median answer to the question, by which year do you think there is a 50% probability that this human-level machine intelligence will have been achieved, was 2050 or 2040, depending on precisely which group of experts we asked. So this was a relatively small survey, and that could be response bias. I think it's the most scientific survey that has been done to date, in that it wasn't just asking random people at a conference who might be self-selected. Nevertheless, not a very good survey, so there needs to be more work. But I think the one conclusion one can draw from this is that it's not a ridiculous proposition to take seriously, the idea that we might have this kind of technology within the lifetime of a lot of people alive today. Like, you might disagree with that, but if you're really confident that this won't happen, you're actually departing from mainstream expert opinion. So in order to get to that place, we will have to overcome a variety of different difficult challenges. So you'll be familiar with some of these, improvements in the way we do transfer learning, concept learning. Now, you might each have your own slightly different list of sort of favorite outstanding problems in machine intelligence. In parallel with these technical problems that we need to solve in order to make machines smart, I think there is a different set of problems that we will need to solve in order to ensure that the impacts of smart machines will be positive. A set of problems perhaps no easier than the problems in the left column. I think there is great uncertainty as to how hard the problems in the left column are. We know that they are not easy, or they would already have been solved, but whether they will take 20 years to solve or 100 years to solve is not something we really can be sure about. There's maybe slightly more uncertainty as to how hard the problems on the right side are, but certainly it seems consistent with all we know that some of these problems could turn out to be really hard, in which case the outcome might depend on us starting to put in solid research effort early on so that we have enough time to work on them, so we have a solution in time. I'm not going to be able to go into great detail. I did write this book a year ago, which some of you might have seen through kind of represented or misrepresented through kind of media summaries and commentaries. But a few of the points that I tried to make is that AI has this enormous potential. It's not just one more cool gadget, one more cool technology. It's really a fundamental game changer. Once you have the ability to automate reasoning. And in fact, if you think about it, once you have machines that are smarter than humans, that's the last invention we will ever need to make. Like, it's not just progress in AI that then translates into progress in all other fields where human intelligence currently is the bottleneck, the limiting factor. All of that further invention can then be done by these smarter than human machines. I argue that superintelligence raises unique challenges. We need to think about this in its own right, not just kind of copy and paste some template that we have for dealing with various other challenges. This raises some unique issues. I argue that there are plausible scenarios in which superintelligent systems eventually become very powerful. Not that we know that this will happen, but in some scenarios, the superintelligent systems themselves, not just the humans who operate them, might become very influential in shaping the world. And that there are sort of superficially plausible ideas for how to try to engineer such superintelligent systems so that they would be safe and friendly to humans, superficially plausible solutions to this control problem that nevertheless turn out to fail. And in fact, one type of progress that has occurred in this field is the development of a slightly better understanding of what the problem is and how certain superficially plausible solutions actually don't work. So, I also argue that, by way of recommendations, that we need to establish a field of inquiry to work on foundational and technical issues related to this control problem, that this is a suitable calling for some small fraction of the world's most mathematically talented people to go into. Not all, not most, not even 10%, but if, say, a few percent of the resources that went into making machines smarter also went into working on this problem, I think that would be good. That the people interested in these kinds of issues want to make sure to build strong research collaboration with the people who are developing machine intelligence, and for many different reasons. So one, obviously, is that ultimately whatever ideas and solutions are produced will need to be implemented by the people actually building the systems, but also because I think there's just a huge amount to be learned in both directions. That insofar as one is concerned with long-term outcomes for humanity, one should factor in the possibility that we might have machine superintelligence. So if you're concerned about global warming, let us say, and the reason for being concerned about that is that you think 100 years from now there might be a certain effect of that, then you should also be thinking about all the other things that might happen in this 100-year window. And AI might be one of those. I make a lot of other points, but also that it might be a good idea to try to embed from an early point in time, like the present time, the notion that if we ever do develop this genuine form of machine intelligence, that it should be done not just for narrow nationalistic or corporate purposes, but for a higher end, that superintelligence should be developed for the benefit of all of humanity and in the service of widely shared ethical ideals, and kind of embed this idealistic motivation in the discipline and in the community. And I know that many of you already believe in this, and I think it might be worth starting to express that and kind of form a consensus around this. It's too big a deal for any small group to kind of monopolize all the benefits. One of the things that have happened recently, as in the last few years, is that what was initially a fairly diffuse and vague sense that it could be important to work on something here. You know, maybe there are both upsides and downsides, ways in which things could go wrong. But that diffuse sense has now also started to crystallize out some more concrete research agendas, including a set of technical research challenges that have kind of been articulated to the point now where you could imagine for some of these assigning a PhD student to try to begin to make progress. I list just a few of them here. Inverse reinforcement learning. This is the idea of applying the intelligence of machines to try to learn what some human actually values or prefers from studying the behavior of that human. And this is, of course, an active area of research, but there are some specific twists in how you might want to pursue this question if what you're interested in is not producing better book recommendations next year, but if what you're interested in is ultimately having some technology available that we could use to solve the control problem for superintelligence. You might, for example, then want to have a very sophisticated model that allows for the fact that humans don't always act in a rationally optimal way. We don't always act in our own self-interest. We don't always act in accordance with our values. So you might want to allow for humans that are impatient over time, that have various cognitive biases, a more sophisticated error model, in other words, than just sort of random noise, or maybe picking randomly from the set of ranked actions below the top. You need maybe a more sophisticated model of the ways that human behavior sometimes diverges from what would be instrumentally optimal. Some others, I'm not going to have time to explain all of these. Corrigibility refers to the idea of how can you design an agent such that it will not learn to resist attempts then to go in and modify its values. How you can design it such that it will not have any instrumental reasons to try to avoid being shut down, such that if you're working with some advanced AI and you're still trying to figure out how to fine-tune its goal system, that it will ideally collaborate with you in that enterprise, kind of point out flaws by your light to how it is constructed, rather than create this kind of adversarial situation. There is theoretical work to be done on the mathematical foundations of inductive reasoning, logical uncertainty, and so on. Subtle differences in your theoretical approach to these issues, which might not manifest, might not matter when you're dealing with subhuman agents that work in a limited domain. But once you have an agent that is smart enough to engage in philosophical reasoning and very long-range planning and to take into account a wider set of factors, some of the assumptions embedded on these parameters might turn out to make a big difference. Transparency tools, like better ways to understand what is going on in a system, to read out what the neural network is thinking so that we can have a better understanding of what systems we build, would seem to be broadly useful. And a bunch of other things as well. And so work on this control problem, including technical work, seems to be valuable, and the time is right for some people to start working on that. Assuming we solve that technical control problem so that we can actually get the machines to do what we decide we want them to do, then there is another set of questions that we then get the opportunity to confront, which is what do we actually want the machines to do? And how do we coordinate globally to ensure that this technology is used for benefiting humanity rather than, say, to wage more effective war against one another or invent better weapons. So here also arises all these issues relation to impacts on human labor market. If you can automate all human labor, what remains for humans to do, etc., etc. Also, in a simple model where you suddenly have a piece of software in a box that can do all the human can do, the first thing you would expect to happen is that a lot of copies of this box to be produced, until the wage that the marginal copy can earn equals the cost of producing another copy. So the electricity bill and hardware rental for building one more AI. And so you imagine perhaps in the simplest model just a Malthusian condition quickly setting in where average wages drop to subsistence level for these digital minds. And there's kind of work you can do to think through there. Another distinctive issue, which is also different from a lot of other technologies that we might want to evaluate, is the fact that when you're building digital minds, you're potentially building something that itself has moral status. Insofar as these digital minds have sentience, most people would think that what their experiences are carry moral significance, just as most of us think that what happens to animals is not a matter of pure indifference. Like it matters if we create unnecessary suffering, say, in laboratory animals. And there is a whole slew of regulations, ethics committees, and procedures that guides the conduct of experimentation on rats, let us say. And one could argue that, say, if we reach even just far before we get to human level AI, if we get to AI that's roughly as capable as a mouse, say, able to navigate cluttered environments and using reinforcement learning and have the other capabilities that would make it roughly comparable to a mouse, then perhaps it wouldn't be ridiculous to start to think about, what exactly are the criteria? Like how far can we go along this path before we need to start to take into account the possible interest of this digital intelligence itself? And of course, that becomes more and more important the more capable the system we get. So if we actually got a literal human in a computer box, I would argue that digital human probably should have the same moral status as the biological humans would have. I think there's a lot of work to be done there to try to understand better what the sort of necessary and sufficient criteria would be. Like what class of algorithms can we be sufficiently confident that here there is no consciousness, here there is nothing that deserves moral status, that we don't need to think about it, and where exactly would the lines be where we need to start to think more seriously about these types of issues. There are further more esoteric issues that I won't really have time to fully discuss here, but once you start to think about where this technology might lead in its limit, if you produce superintelligence that can create very detailed virtual reality simulations, and you start to think about how that superintelligence might reason about its place in the world, it might assign a high probability to simulation hypotheses, that is, that it is living in some kind of virtual environment. Maybe a lot of AIs live in virtual environments, and maybe it would be a reasonable thing for this powerful reasoner to also assign a fairly high credence to it living inside a simulation rather than directly interacting with physical reality. And maybe that will, in certain situations, lead it to behave in unexpected ways because it's actually trying to create plans that take into account this possibility, etc., etc. There's no particular reason to think that we have exhausted even the basic types of challenge and consideration that might need to be solved in order to get a safe transition to the machine intelligence era. And so I think that there has been a significant improvement, even just over the last year, in terms of awareness of some of these issues within technical community. There's been some discussion. I think the next challenge now is to channel this general awareness into some actually constructive research, for some people actually to work on this on a full time and begin to take the big questions apart, break them down into smaller questions, and start to make progress. That's one of the things that we will be trying to do over the coming years, and there's a little bit more funding streaming into this area as well. So there will be a number of other groups also springing up. The Leverhulme Center was mentioned earlier. That's one example of that. So broadly speaking, I'm kind of optimistic about the current direction in which this type of enterprise is moving. But I still think we have a long ways to go before we are allocating anywhere near the optimum amount of attention and sort of quality-adjusted research effort to these questions relative to their importance. Thank you.
Each year, Microsoft Research hosts hundreds of influential speakers from around the world, including leading scientists, renowned experts in technology, book authors, and leading academics, and makes videos of these lectures freely available.